Good morning, ladies and gentlemen. Happy Thursday. Today is March 19th, 2020. It's teacher Vasquez coming at you from my home crib with my dolphin Sushi. Say hello, Sushi. Hi, guys. Today we're going to be taking a look at lesson 12, parallel and perpendicular lines. Let's jump right in. It's now all on the line, guys. Everything. Here we go. 12.1, question number 1. Write an equation for the line that's perpendicular to line N and whose y-intercept is 0, 5. How do we graph perpendicular lines? Well, first, we need to understand what the slope of the line we're given is. That way we can find the slope of the one that's perpendicular to it. So what is the slope of this line? Well, we can see by those 2 points at the highlight that the graph seems to go to the right 5 and down 2. That would make our slope, change in y over change in x, negative 2/5. Now, if we want slope that's perpendicular to that one, we're going to need to take the opposite reciprocal. So take that negative 2/5, flip it upside down, and make it the opposite sign. So now our slope is positive 5/2. Since we have to graph this line using that slope and the y-intercept, it's probably easiest to write the equation of the line in slope-intercept form. Y equals mx plus b, the one we all know and love. You simply plug everything in. There's your equation for your line. If we were to graph this, you start at the 5, you use the slope, and that's what it looks like. Nice and perpendicular. Let's take a look at the next one. Number 2. Write an equation for a line that's parallel to line N and passes through the point 3, 1. So we already know what the slope of this line is. It's negative 2/5. If we want to write a line that's parallel to this one, then we need to make sure that they have the same slope. So our line also has to have a slope of negative 2/5. Now we have a slope and we have a point that the line needs to go through. So in this case, the easiest form would actually be point-slope form of a line, which is what you guys have been learning about while we've been away. What we want to do is take the point that we know it goes through and replace that with the h and the k. So the 3 is our h, the 1 is our k, and we simply plug that in with the slope to get the equation y minus 1 equals negative 2/5 times x minus 3. So you would actually graph this line by starting at the point 3, 1, using the slope to get the rest of the points. It should look something like that. If we put the first line back in there as well, it actually looks like the blue line is perpendicular to both line N and this purple line that we have now. That's probably not important. Next, we are going to be talking about 12.3, looking at different lines. Question 1. Line L is represented by the equation y equals 2/3 x plus 3. We want to write the equation that's perpendicular to that line and goes to the point negative 6, 4. Now, this is very similar to the question that we just did. We know we need to find the slope of that line, which is going to be 2/3, and make sure we have a slope that's perpendicular to that and goes through that point. So we're going to use point-slope form and write the equation of the line, just like that. Question 2. Now we have to write an equation that's perpendicular to line P, but passes through the point 3, negative 2. So once again, take the slope, make sure we write the perpendicular slope. We're going to use point-slope form and write our answer like that. Question 3. What do you notice about lines L and N? Does this always happen? Well, it's pretty obvious by looking at these equations exactly what they're talking about. But in case you don't really see the relationship yet, let's take a look at their graphs. Here we have line L, and the first question was asking us to write an equation of a line that's perpendicular to line L and goes to the point negative 6, 4. When graphing that, it looks like this. The next question asks us to draw a line that's perpendicular to the blue line and goes to the point 3, negative 2. When graphing that, that looks like that. And we can see that the green line and the line we started with are parallel to each other. So what do we notice about lines L and N? Well, they're parallel to each other. Does this always happen? You bet it does. Why? Well, this goes back to a topic that we learned in Unit 1 at the beginning of the year. If two lines are perpendicular to the same line, then those lines must be parallel to each other. That's all the time we have for today, folks. So until next time,